Welcome to lesson 4.2 on graphing linear equations. So the first thing we need to know is what exactly a linear equation is. An example of an equation with two variables would be 2x plus 5y equals 8. The reason it says two variables, we have both an x and a y value. The solution of that equation would be x and y, which would become an ordered pair. This means that it produces a true statement when the value of x and y are substituted into that equation. All right, so for example, which ordered pair is a solution of 3x minus y equals 7? And they give us four different options here. The best way to go about solving this problem is just to go in and guess and check. So we are going to plug in my x value and my y value of my first option here, 3, 4, into this equation. So I'm going to go 3 times 3 because I have 3x minus 4 because that would be your y equals 7. So then 3 times 3 is 9. 9 minus 4 is definitely not equal to 7. It equals 5, so this is not a solution to my equation. All right, so we are gonna just guess and check the next one. So we know A is not a possibility, so we'll try B. So we're gonna do 3, my x value is 1, so times 1, minus negative 4, so minus negative 4 equals 7. 3 times 1 equals 3. Minus negative 4, I can actually turn into positive 4. So if 3 plus 4, we know that this in fact does equal 7. So we're lucky it's option B. We don't have to go through all four problems. So B would be your ordered pair that is a solution to the function 3x minus y equals 7. All right, so the next thing we want to do is actually learn about graphing the equation. So a graph of an equation in two variables is the set of points in a coordinate plane that represent all of the solutions of the equation. Now yesterday you briefly looked at graphing those points using an XY table, and we're going to use that same idea today, and we're just going to take it one step farther. Okay, so if I'm given the example, graph the equation negative 2x plus y equals negative 3. The first thing I'm going to want to do is step 1 is going to be to solve the equation for y. Okay, this is why in chapter 2 they had you solve for y, and they said solve the function. So we're going to add 2x to both sides, so then I'm going to get the equation y equals 2x minus 3. Then I'm going to make an xy table, which is what they're showing down here. You will probably, they don't give you your domains, unlike last section where they actually gave you domain values. My recommendation would always be to do a couple negative numbers, a 0, and then a couple positive numbers. It makes sure that your graph looks complete. Okay, so then I'm just going to plug in my values into my new equation here, which is the y equals 2x minus 3. So I'm going to do negative 2 times 2, plug that in, which would be negative 4. Negative 4 minus 3 is going to be negative 7. Same thing with negative 1, same thing for 0, 1, and 2. That way I have 5 sets of coordinate points. I have negative 2, 7, negative 1, negative 5, 0, negative 3, 1, negative 1, and 2, 1. Okay? we're just going to plot these points on a coordinate grid. So if you look, we have -2, 7, the -1, 5, the 0, 3, the 1, -1, and the 2, 1. Okay, this right here is your graph and pretty much your solution. Okay, notice that when you plot the points, you need to draw a line through them. Make sure that you extend your line a little bit past your points, add arrows to them because it is in fact a line, not a segment. Okay, and then the last, and so that's just the last step. Okay, so you have 1, 2, 3, 4 steps to this whole graphing the equation idea. All right. So the another idea that I want you guys to pay attention to is equations of horizontal and vertical lines. Whenever you are given a an equation that looks like y equals some number, so for example, if you have y equals 2, okay, then you would just make a straight line across the y-axis at, let's call this 0.2, okay? And then the exact opposite here for the x. If you have an equation where, let's say this is x equals 2, then you would draw an up and down or a vertical line, and that would be at 2. A handy way to remember this is if you have a horizontal line, it goes like this, okay? And then your vertical line is straight up and down. I don't have a fancy picture for that one. All right, so let's look at an example here. So we have graph y equals b and x equals a. So we're going to graph y equals 2 and x equals -1. All right, so let's just go through this real quick. So the first one, for y equals 2, I'm just going to create that straight horizontal line across the y-axis at 2. Okay. And then for the x equals -1, that is going to go vertically across the x-axis at -1. All right. Now notice that the y, so solution A, is a function, whereas b, the x equals -1, is not a function. This one passes the vertical line test. This one totally fails it because it's a vertical line. All right, so that's something to know for the future. All right, the last example we're going to do is just graphing another linear equation. So we have y equals -1/2 x plus 4. They say with a domain of x is greater than or equal to 0. So that means that you're going to use x values that are larger than 0. Then identify the ranges of the function. That means just identify the y values. All right, so let's go through this step by step. First step, make a table. So we're picking numbers above 0 because that's what it told us to do with the domain. So in this case, they picked 0, 2, 4, 6, 8. You could have picked 0, 1, 2, 3, 0, 2, 5, 7, whatever, as long as they were larger than 0. They plugged in their x values into this original equation, solved for their y values, which I'm assuming at this point you know how to do. And then we're just going to plot them. So we have 0, 4, 2, 3, 4, 2, 6, 1, and 8, 0 as my coordinate points. I'm going to graph it right here. Now, notice that my my graph only has an arrow on one side. Because it said that it needed to be larger than 0, it has to end at 0, okay? So you could say that the range is from 0, 0 all the way up to 4, 0. Okay, because that's where it crosses over the x-axis. So it says identify the range. From the graph, you can see that all points have a y-coordinate of 4 or less, so the range of the function is y is less than or equal to 4. Okay, so that's how you would, when they say identify the range, that's how you would identify it as an inequality. All right, that's all I have for you. Let me know if you have any questions tomorrow. Thanks. You guys.